Hi, welcome to Math Expressions. In today's video, we'll be looking at Fredom's theorem part 2, and by the end of this video, you will learn how the theorem works when the angles are facing opposite direction. So stay with me in this video as we do this together. Alright, in our previous video, we discussed Fredom's theorem part 1, and in that video, we only focus on how the theorem works when the angles are facing the same direction. As you can see from this diagram here, which is the diagram we used in our previous video, angle C in the green triangle and angle A in the red triangle are facing the same direction. And angle B here between these blue lines is the angle between these two triangles that are drawn in the circle. So I don't have to emphasize much on this. If you want to know more about Fredom's theorems when the angles are facing the same direction, you can go back to our previous video so that you can have a full understanding of what Fredom's theorem is all about. So let's go back to what today's video is all about. Like I said, in today's video, we will be discussing Fredom's theorem, but in this case, we are going to find out what happened when if the angles are in opposite direction. That's what we're going to discuss today. So this diagram here is a circle with two triangles. As you can see, the green triangle and the red triangle with their base lengths, these blue lines here. So in today's video, we'll focus on how to calculate this angle B, which is the angle between two triangles that are drawn in a circle if the angles are facing opposite direction. So the first thing we're going to do is to find out how to calculate for angle B naught. That is angle between these two triangles. And in my own word, I called it other sides of B, which is also known as B naught. So let's get started. And it says, if this side is equals to B, then other side is equals to B is equals to 180 minus B. Why? Because they are angles on opposite segment. Angles on opposite segment are supplementary, as we know from our basic geometry. But B is equals to C minus A. That is from Fredom's theorem. From our previous video, we proved that B is equals to angle C minus angle A. So that's from Fredom's theorem. Therefore, other side is equals to 180. If you rearrange the equation, we have a equation will look like this. Therefore, other side is equals to 180 minus C minus A. Hence, other side of B is equals to 180 minus C plus A. If you factorize the equation, so let other side of B be equals to B naught. So in a simpler term, we can say that is alternatively angle A plus angle B naught plus angle C is equals to 180 degree. This is the equation that connects these three angles, that is angle A, angle B naught, and angle C. Or you can say angle B naught, the absolute value of angle B naught is equals to 180 degree minus angle A plus angle C in bracket. Now let's look at worked example. From the above diagram, if angle BAC is equals to 127 degree and angle BCD is equals to 124 degree, find the value of angle BDE from this above triangle here. Angle BAE, that is A, and angle BCD, that is angle C. Then we have to find the value of angle BDE, that is angle B naught, and that's what they ask us to find in this exercise here below here. So now solution, let's see how we can solve for this. Let angle BAC equals to A which is equals to 127 degree. Angle DBE B, let it be equals to B naught, let's call it B naught, and which is equals to unknown. That's the value we have to find. And then angle BCD, let it be equals to C and is equals to 124 degree. From this our equation here, we have angle A plus angle B naught plus angle C is equals to 180 degree. And let's solve for this. So if you rearrange this equation, we have something like angle B naught is equals to 180 degree minus angle A plus angle C in brackets, which is also equals to 100. And if we plug in these values here, our equation will look like angle B naught is equals to 180 degree minus 127 degree plus 124 degree in bracket, which is equals to 180 degree minus 251 degree. Angle B naught is equals to minus 71 degree. So taking the absolute value of B naught, the absolute value of B naught will be equals to 71 degree. Therefore, angle B naught is equals to 71 degree. So that is it. So therefore, this angle B naught here is equals to 71 degree. So then, and your question now will be, this other side of B now, where is it referring to, which we call B naught? If this B naught is other side of B, where is B located in this diagram? Okay, let's go back to the diagram we use and prove this Fredonm's theorem. If you go back to that diagram, which is this one, you will look at this diagram. This is the actual B, and in this video, that one we call B naught, I refer to it as other side of B. So where is that other side of B in this diagram? All right, other side of B is that angle you created. That is that angle you created when you try to separate these two triangles, which is triangle ACB and triangle AEB. So the angle between them, when you try to separate them, is the angle referred to as B naught. Now let's look at this. So when I try to separate this triangle, like this blue line being the base length of the other triangle, let's assume is the base length of triangle AEB. So when we try to separate it like this, so when you open it like this, let's say the angle that is formed here, is referred to that B naught. But in this case, B naught is equals to 0 because B naught is equals to 0. So is at this point is somehow here, but is equals to 0. So B naught does not exist in this diagram here. Why? Because from that theorem that we proved, we just got earlier in this video, like this theorem. Let me show you how everything works so that you have a full understanding of it. This theorem we have, which says other side of B is equals to 180 degree minus angle C plus angle A, or this one to be precise, this one here. So from this equation, you will see here that angle B naught is equals to 0. So now this is the formula here, that formula that we got earlier in this video, which says B naught is equals to 180 degree minus angle X plus angle C, minus angle X plus angle C. And this is angle X here, or the angle here, and angle C here, or the angles here. And we all know that the angles on opposite segments are supplementary. Therefore, if you sum these two angles, it will give you 180 degree. And this formula says angle B naught is equal to 180 degree minus angle X plus angle C. Then angle X and angle C is theoretically 180 degree. Therefore, 180 degree minus 180 degree is equals to 0. Therefore, B naught is equals to 0 in this case, in this diagram. That's why you do not see anywhere labeled B naught in this diagram. Then another thing to know is that if angle A is equals to 0 and angle X is equals to 180 degree, if we stretch this angle till it becomes 180 degree, then the sum of angle B, which is the angle here, and the sum of angle B naught, which is the angle that will form that moment to try to separate this triangle, the angle that will be here will be equals to 180 degree. Why? Because when this triangle, when this angle A becomes 0, definitely angle B will be equals to C. And when angle X is equals to 180 degree, then angle B naught, that angle that will be formed here, let me open this thing. That angle that will form here will be equals to 1, that angle that will be formed here will be the supplement of angle B. So adding two of them together will give you 180 degree. And that is it for this video. And if you have anywhere confusing in this video, I would like to know where you are finding it difficult to understand in this video. Actually, what we're doing here is not a rocket science, just a simple basic school geometry. Yeah, so there's nothing too hard to understand here, and that is all I have for you in today's video. Like I said, in this channel, we always discuss some of the newest theorems or some newest topics that somehow, like, we always discuss some of the newest topics. Like this Fredonm theorem is very new, and in this channel we're introducing this Fredonm theorem to the world of mathematics. And this is a very helpful theorem. As you can see, is a theorem that when you have a case like this, the theorem shows the relationship that is between these three values here, which is angle A, angle B naught, and angle C. And that is all I have for you in today's video. If you find this video helpful, please like, comment, and share this video so that it will get to another person who might need this video. And also, if you have a question or you have a question or you have a contribution, I would like to know whatever your thought is in the comment section, and I will be glad to reply to whatever thing you drop in the comment section. So thank you for watching this video, and I hope to see you in my next video. Have a lovely day.